So this is the second programming class. I will just write toggling LED code, but not like before code. Here I will write in different format because sometimes you will find the code written in something but other write in different format. So because of that, it's good to learn how to write code in different way. So here I'm using TM4C123CA6BM Jiva microcontroller. So this is the main program. It is saying the system control to use this 32-bit register RCGC GPIO and give a short clock source to the port you want to use in your code. Here I'm choosing the port F because as we know 2 is represented by this and 0 is represented by this. So this pin 1, 2, 3, 4, here I will say bit 0, 1, 2, 3, 4, 5. So this bit represents port here because this RCGC GPIO says to choose a particular port by giving clock source to it. So here the pin or the bit is representing the port. So this become port A, port B, port C, port D, port E, port F. Okay, so it represents port F or GPIO F. Port F or GPIO F is same. So this GPIO F, here GIR means it is giving the pin, setting the pin as input or output pins. But here I'm writing like this, so it is setting it as output pins. But if I write something like this, that means it is setting it as input pins. But here I'm setting it as output pins. Okay. So here I'm setting it as output pins, but which pin? So 0E means this. So 0 is represented by this, and because in ARM the whatever you took is represented by in hexadecimal. So 0 is represented by this and E is represented by this. Okay, but which pin? This is pin 0, pin 1, pin 2 and pin 3. So you are choosing pin 1, 2 and 3 only. Okay, you are choosing only pin 1, 2 and 3. So in order to set this as an output bit, you have to set it How to set it? By writing 1 to it. So you are writing 1 1 1. That means you have set the pin 1 2 and 3. Okay, as output pin. So this one is you are making the pin as digitals and not analog, because we are not using any analog functions here. So 0E means so making it digital means you have to set the pins, but which pin you are using? You are using pin 1 2 and 3, right? You have to set means, how to set means by writing 1 to it, right? So okay, you write 1 to each of the pins you have chosen which pin you have chosen 1 2 3, right? So that's why okay, you have you set it by writing 1 to the pin you have chosen. Which pin you have chosen? Pin 1 2 and 3. Okay, this one is 1 2 and 3. So you can use this. You are now okay set the pin as digital. That means you can use it for digital functions like UART, I2C, and then all those stuff, SPI, etc. And these are just setup of which port you have chosen by giving clock source to it, which pin you have chosen, and then you are making it digital. So these are the next code is going to okay, loop. So you are okay giving data to the port you have chosen. So what type of data you have chosen? It depends on the pin okay you have chosen. Okay, which pin you have chosen? You have chosen pin 1 2 and 3, right? So okay, you have chosen pin 1 2 and 3, right? So in order to set this pin, how to set? By writing 1 to it, right? So okay, you have set the pin 1 2 and 3. You have set the pin 1 2 and 3. That means you are giving data to it. Okay, data means setting the pins means you are it's like it's same as giving data. Data, if you make the pin set, that means you are supplying data. If you doesn't set the pin means you are not supplying data. That means you are making the pin on. On means the electric current will pass, right? That's why. Otherwise there will be no electric current, so it will that means the pin is in off condition, means 0, right? That's why. So you are giving some delay here to make okay slower okay the process. Here I'm not giving any data okay to the pins. That means I'm not setting the pins. That means I'm not supplying any kind of currents to the pins. So here okay the lead will be on when this port means the pin of that particular port, when those okay pins are connected to LED, so current will pass and the lead will be on and the lead will blink. But here you are not giving any data. That means you doesn't turn on the LED, you doesn't apply any electric current or set the pin on, so the lead will be off, LED, So here it will blink the lid, but it will off the LED here. But this happened very quickly, so you need to give some kind of delay to make it blink slowly, because if it blinks slowly on and off, then you will be able to see it with your eyes. But if it blinks very fast, you won't be able to see. That's why we are giving some delay. Okay, I'm writing simple delay code here. I'm taking two variable and then I'm writing outer loop. So I'm taking two variables, and here I'm doing the first outer for loop, and this one is second inner for loop. So this will run one time, and then this will run 3180 times, and this will run again one time, and this will run again 310 times. That means you are supplying n value here 500. That means it will run 500 times. Okay, so in details it will be 500 into 3180. So 500 into 3180, that much millisecond. It will make a delay, make the code slower. Okay, in processing, so the blinking, it will blink here, it will blink, and then it's making the code wait for some times, and then it will off so that you can see the blinking. And the last sections of the code is system init. This is not so important. So this is the last sections of the code, and this line of code is saying the system has this register CPACR, and by using this register we are supplying the data F. This one is F. So F means, so this system, it has this register, and using this register it is supplying this value. This value is okay, F represent 1111, and this 21 will turn a coprocessor C11, and this will turn the coprocessor C10, and this coprocessor is required to turn on so that the ARM coprocessor can use the floating point units of the that the system has, in order to, because when you're writing the code you may be using the float values, the double values, because of that. So that's all for this session. Thank you all.